Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on statistics. So there are three things we're going to go through in this video. The first, we're going to review mean, median, and mode. You've probably done it a million times, but we're going to go through it again because you need it for the other two things that we're going through. The second thing we're going to talk about is skewness. And the third is something called the standard deviation. So the last two should be new for you. So let's get into reviewing the mean, median, and mode. So on your screen, I've put two sets of data, A and B. So these, I'm pretending, are two classes, and each score is a test score. So we're going to calculate the mean, median, and mode of each. So let's start with the mean, which is also the average. So to find the mean or the average, you add up all the scores, divide by how many there are. So for A, if you add up all the scores, you can obviously use your calculator, you get 1245, you divide by 15 because that's how many there are. So you get 83. So the mean of class B is similar. You add them all up and you should get 1218. This time there are 16 scores. And so if we do 1218 divided 16, we get 76.125. There is no reason that the mean needs to be a whole number. So now we'll take a look at the median of both classes. So to find the median of a set of scores, those scores need to first be put in order. So firstly, we're going to take all the scores from Class A and put them in order. So I've put all of the scores of Class A in order from smallest to largest. So the median is the middle score. Now, in Class A, there are an odd number of scores, which means the median will be one of the observations, one of the scores. It's hard to know which one, so a formula you might like to use is this. So if you're not sure which is the middle score, you can take n, the number of scores, add 1, and divide by 2. That doesn't actually tell you the median, it tells you which score is the middle one. So in A, n equals 15 because there are 15 scores. So if I do 15 plus 1 over 2, I get 8. That means that the median is the 8th score. It doesn't matter whether you consider it the 8th smallest or 8th largest, they're the same thing. So go 1, 2, 3, 4, 5, 6, 7, 8. So 80 is the middle score. There are the same number of scores below it as there are above it. So there are 7 scores less than or equal to 80, 7 scores greater than or equal to 80. So the median for Class A is 80. Now let's look at Class B. Well, Class B, the scores are already in order. But now there are 16 scores. So 16 plus 1 divided by 2 gives you 8.5. What the hell does that mean? How can we have the 8.5 score? Well, when you have an even number of scores, the median is going to be the average of the two middle scores. So 8.5 means that we're going to take the 8th score and the 9th score and go halfway between them. So let's go to B. We have 1, 2, 3, 4, 5, 6, 7, 8. And then 9th score is 79. So once again, there are the same number of scores below these as above them. So there are 7 scores less than or equal to those two I've circled, and there are 7 scores greater than or equal to those I've circled. So B, the median, will be the average of the two middle scores. It's the average of 79 and 79, which is, of course, just 79. So the median of A was 80, the median of Class B is equal to 79. So we now find the mode of each class, and that's the easiest to find. It is the most common score, the score that occurs the most. Now in A, it's easiest to find the mode now that we've put them in order. We see that there are 3 scores of 74, but also of 86. So for A, there are actually 2 modes, 74 and 86. They are both the most common scores. If there are 2 modes, we say that the data is bimodal. So Class A is bimodal, bi meaning 2, modal mean modes, it has 2 modes. If we look at the mode of Class B, Well, in Class B, 81 is the only score that occurred 3 times. There were plenty of scores that occurred twice, but 81 is the most common. So because Class B only has one mode, we call it unimodal. Okay, so remember, the mean is the average, add up all the scores and divide by how many. The median is the middle score when there's an odd number of scores, and it's the average of the middle 2 scores when the number of scores is even. And remember, this formula can help tell you which score is middle. And then finally, the mode is the most common score. Data can be unimodal if it has one mode. It can be bimodal if it has 2 modes. If it has more than 2 modes, it's called multimodal. Note, if a data set has no numbers repeated, then it has no mode. All right, let's look at doing a problem now involving the mean. So I'm going to rub some of this out. Please pause and copy down if you need. So let's have a go at this question here. Another student from Class A takes the test, and afterwards the mean reduces to 79. We can calculate the score of this student. So what we do is we figure out what is the sum of scores before the student took the test, and then what is the sum of the scores after the student took the test. Because we know that the mean equals the sum of all the scores divided by n. So that means if you take the number of scores and times by the mean, that tells you what all the scores add up to. So we already knew beforehand that all of the scores added to 1245. If we weren't given the individual scores, it wouldn't matter. So the original sum, which I'll call OS, would have just been, so there were 15 scores, the mean is 83, so they add up to 1245. So the sum after the student took the test, so if the student takes the test, there would now be 16 scores in Class A, and if the mean is 79, we just multiply them together to get 1264. So the scores, the sum of the scores before he took the test was 1245, afterwards was 1264, and therefore the student must have scored 19, because 1245 plus 19 is 1264. Okay, that's all there is. Now we're going to look at skewness. Again, please pause and copy down this example if you need. So the reason we're now turning our attention to skewness is that the mean, median, or mode by themselves don't tell you much about the distribution of the scores in a class. If I tell you that the mean of a class was 83, it doesn't tell you that much. We could have had everyone score very close to 83. Perhaps you have, a lot of students score in the 90s, but there are a few people who scored really low, like in the 20s, and it brought the mean down. We just don't know. So it turns out comparing the mean and the median of a given dataset can tell us a bit about the distribution. So if the mean is greater than the median, we say that the data is positively skewed. If the mean is less than the median, we say that it's negatively skewed. And if the mean is approximately equal to the median, so they're very close, we say the data is not skewed or symmetrical. So in our previous calculations, we found that for Class A, the mean was 83, and we actually found the median was 80. So that suggests that A is positively skewed because, of course, the mean 83 is greater than the median of 80, whereas what we found before for B suggests that it is negatively skewed because we calculated that the mean was 76.125 and we calculated the median was 79. Okay, so we're now going to look at what this looks like when we put our data into stem and leaf plots and histograms. So once again, I'm going to rub out the stuff below the blue writing. Please pause and copy down if you need. So we're going to create a back-to-back stem and leaf plot. So remember, what you have is a stem, which is basically the number of tens. So for our scores here, they went from 50s all the way up to the 90s. So on one side, we're going to have Class B, and one side we're going to have Class A. And under Class A and B is the leaf, where you put the individual scores. So for Class B, it's easy to do because the data's in order. We put a 9 here. That represents the score 59. And then all the scores in the 60s, like so. So we're going from smallest to largest. And then when we get into the 70s, we're again only writing the units. So this score here means 74, this one here means 79, and so on. So I've now put all the scores from both Class A and Class B into a back-to-back stem and leaf plot, and this will display skewness a bit better. So what skewness is actually telling us, that little calculation before where we compared the mean and the median, what it tells us is whether or not scores are clustered towards the maximum, the minimum, or neither. So remember, Class A had a positive skew, and it's very evident from this stem and leaf plot. It has scores clustered towards the minimum. So the minimum score for Class A was 74. It has a lot of scores here clustered in the 70s towards the minimum, and then you see it has fewer scores as you go on, fewer scores as you get higher. Whereas for Class B, the opposite happens. Remember, Class B was negatively skewed. So the maximum score is 86. It has more scores clustered towards this maximum score. And then as you get lower, you have fewer scores. So this is tricky because it sort of works the opposite way than you'd expect. Positive skew means there are more low scores, as in more scores closer to the minimum, whereas negative skew means there's more high scores closer to the maximum. Now, obviously, what happens is if it's not skewed, the scores are clustered towards the middle. So that is the stem and leaf plot. Now, what I'm going to do is I'm going to make histogram for both A and B. So again, please pause and copy this down if you need. So remember, a histogram is like where I have bars for each of the different scores. Now, because there's such a diversity in scores here, it would be easier for me to group them, just like I did for the stem and leaf plot. So I'm going to group the scores in the 50s, 60s, 70s, 80s, and 90s for both A and B. I'm going to set up two histograms, one for Class A, one for Class B. So histograms always have F, the frequency on the vertical axis, and the higher the bars, the higher the frequency. So if we look at Class A, there were no scores in the 50s or 60s, but there were 7 in the 70s. So I draw a bar up around the 7s, then there were 5 scores in the 80s, and then there were 3 scores in the 90s. So for Class B, sort of the opposite happened. There was 1 in the 50s, then there were 3 in the 60s, 5 in the 70s, and then there were 7 in the 80s. So this shows you skewed histograms. Positively skewed histograms, you can see that the highest bar is at the minimum. So the highest frequency of scores is at the minimum, whereas the opposite for Class B, the highest bar, the highest frequency of scores occurs at the maximum. So these are the shapes you'd expect. This for positively skewed and this for negatively skewed. Of course, symmetrical means it's not skewed. You'd have a histogram that looks like this. The bars would be highest in the middle. So if the bars are highest towards the minimum, we say it's positively skewed. Highest towards the maximum, we say negatively skewed. Once again, it works sort of in the opposite way than you'd expect. More high scores, negatively skewed. More low scores is positively skewed. I just want to say quickly though, skewness doesn't tell you how high or low the scores were in general. We can see clearly that A is positively skewed. So it has more scores closer to the minimum and B has more scores close to the maximum. But clearly Class A did better in this test than Class B. When we calculated it, the mean and the median were higher for Class A, okay? So negatively skewed doesn't mean the scores are good. Positively skewed doesn't mean they're bad. All right, now we're going to go on to the last thing, which is standard deviation. So we're just taking a quick look at standard deviation. It actually takes a long time to calculate and it's very painful. Most people get computers to do it, but we're going to practice doing it by hand. So what does the standard deviation actually tell you? Well, it's a measure of spread. It tells you how spread out the data is. We looked at a measure of spread in the range, but the range isn't a good measure because it only includes the largest score and the smallest score. What the standard deviation deviation basically tells you is the average each score differs from the mean. So if the standard deviation is very low, it means most scores were close to the mean. And if the standard deviation is high, it means that a lot of scores were away from the mean. So to give you an example, let's say I have 3 scores whose average is 12. So if I have the scores 11, 12, and 13, you can see all the scores are pretty close to the mean. It turns out in this case, the standard deviation, which I'll call S, if we worked it out, it would be 0.816, blah, blah, blah. It goes on forever. If I had 3 scores whose mean was 12, and the scores was 0, 12, and 24, it turns out the standard deviation of these scores is just under 10. It's about 9.8. So the standard deviation is a lot higher in the blue scores than the red, because the blue scores are more spread out. So let's look at an example where we go through and calculate the standard deviation. So let's say I have these 5 scores in yellow, 8, 14, 17, 23, and 28. We're going to calculate the standard deviation. So the first step is to calculate the mean. So if you add these up, they actually add up to 90, so the mean is 90 over 5, which is 18. So that's first step done. The second step, we take each score, subtract the mean. And then we're going to square our answer. So 8 minus 18 gives us minus 10. So this row here is going to be the score minus the mean. X bar means the mean. So then 14 minus 18, 17 minus 18, and so on. Now what we want to do to complete step 2, we want to take the values we've just got where we subtracted the mean, and we want to square them. So we square negative 10. If you square a negative, you always get a positive. We get 100. Negative 4 squared is 16. Sorry, this is squared. Negative 1 squared is 1, and so on like that. So that is step 2 done. Step 3, we'll want to add these up. So we're going to go 100 plus 16 plus 1 plus 25 plus 100. So the answer we get, if we add all these up, is 242. Next, what we do, so that's step 3. Step 4, we divide 242 by the number of scores. So we do 242 divided by 5, which is 48.4. So that's step 4, and step 5 is to square root it. So here, our final answer, the standard deviation equals the square root of 48.4, which is approximately 6.96. That's just to 2 decimal places. So what that tells us is that the average distance, I'm using average in quotation marks, the average distance of each score from the mean is 6.96. So it, along with the average, tells you about the distribution of scores. So if I said to you, let's say that the average of a test was 80, if the standard deviation was like 1, that means pretty much everyone scored between 79 and 81. The scores were very close together. If I tell you that the average of the class was 80 and the standard deviation was, say, 20, that means the scores were more spread out. Most kids scored between like 60 and 100. All right, so you just need to know how to calculate the standard deviation now. It is a pain to calculate, but it's really good for us to understand what's going on. All right, sorry for the long video. Thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.